my name is Elizabeth, and today we're going to be going over another Pauli exclusion principle. So if you watched one of our previous videos, it also involves Pauli exclusion principle, but it's written a little differently. Over there we have the little arrow diagrams, and we used those to figure out which one was incorrect. But this time we're going to be using the number and letters configurations. So let's keep in mind what Pauli exclusion principle is, and it just means that no two atoms can have the same four quantum numbers. And that those quantum numbers have to follow very specific rules. So one of those rules is that in the s orbital you can only have 2 electrons. In the p orbital you can have up to 6 electrons. In the d orbital you can have up to 10 electrons. And in the f orbital you can have up to 14 electrons. So you can have less than these values, that's fine, but it just can't have any more than those values. Also, you have to be able to be going in the direction of increasing energy. So if you're reading your periodic table in order to find out your electron configurations, you should read it like a book from left to right, and you shouldn't skip any shells. So one exception there, so it's pretty normal. You go through like 1s2, 2s2, 2p6, 3s, 2, 3p6, but then when you get to 4s2, if you notice, you're going to hit your transition metals. Those transition metals are n-1, so it'll actually be 3d10 following that, and then you go to 3p6, etc., etc., etc. So notice that here we kind of have a little blip in the system, and it's because the transition metals, that d orbital, is n-1. So that's something to keep in mind as well. And with that, I think we're ready to go on to our practice problems over here. So let's look at these individually and see what we can find is incorrect in each example. So in the first example, I have 1s2. My s orbital can have up to 2 electrons, so that is okay. And then here I have 2s2, which is also okay because the s orbital can have up to 2. And then I have 2p7. Here, I should only have up to 6, so this needs to be less than or equal to 6. Since it's 7, that is not a correct electron configuration, so it should probably be 2p6, 3s1 or something along those lines if you want to keep the number of electrons consistent. So let's go ahead and look at the second one. I have 1s2, which again, the s orbital can have up to 2 electrons, so that's fine. 2s2 is also fine. 2p5. So you might look at that and be like, oh, that's not 6, that's incorrect. However, it can be anything less than 6, so this one is also okay. It just means you haven't reached the end of that orbital. So this one's fine, there's nothing wrong with him. Let's go on to C. So I have 1s2, so that is okay. 2s2 is also fine. 2p6, 3s3. No, that's not okay, right? Because here we have to make sure that there are only, it has to be less than or equal to 2. All right, so here, this would have to either be just 3s2, or it can, the electron, to keep the electron number consistent, would have to be 3d8. 3d7 here is also okay. It's not up to the full 10, but that's okay. It doesn't have to be a full shell. It just has to be less than or equal to 10. So let's look at the last one. I have 1s2, which is fine, 2s2, 2p6, 3s2, and then 3d8. So that is also fine because it hasn't reached the full 10 yet. So this one's also okay. One thing I would keep in mind though is that it should probably go to 3p for both of these. It should probably go 3s2, 3p6, then 4s2. So the 3D shouldn't come after the 3s, and the same thing here. Should be 3p6, then 4s2, and then the 3d. So that's another thing that could be incorrect. So this one might not be completely incorrect. Should be able to, you have to go from the lowest energy level, working your way up to the highest energy level. Since the D shell is so big, it's going to have to occupy a higher energy level than the p or the s orbitals. So this should be inserted into here before you go into the d orbital. So as you can see, the first one is incorrect because p has to be less than or equal to 6. Here we have this that has to be less than or equal to 2, and also we kind of skipped a couple shells in both C and D in order to and we skipped to the D, which we can't do that. We have to make sure that we're going in order of increasing energy. So the only one here that actually follows Pauli Exclusion's principle is going to be letter B with 1s2, 2s2, 2p5. So that's how you use Pauli Exclusion principle to be able to tell which one is following the Pauli Exclusion principle correctly by knowing the number of electrons that can be found in each shell.